Okay, now we're going to talk about limit laws. Limit laws help direct you or guide you on how you can simplify or evaluate limits. So, one limit law is the limit of the sums. Okay, so this is what that means. So you've got this limit, and there's two things as part of the function, right? So maybe you've got an x squared plus an x cubed. The limit of the sums is the sum of the limits. So what this means is you could see it this way, or you could rewrite it as the sum of two separate limits. So for example, if you have the limit as x approaches 1, 3x squared plus 2x, because it's a polynomial, you can use direct substitution. You substitute in 1 for both of those and you get 5. So this is the limit of the sums. The sum of the limits would say, you take the limit as x approaches 1 of 3x squared, which is 3, plus the limit as x approaches 1, 2x, which is 2. Add those together, you get 5. All right? The limit of the difference is the difference of the limits. So you're going to take this one thing and rewrite it as two separate limits with a subtract sign in between them. The limit of the products. So inside the parentheses of the one limit, is the product of the limits. Write it as two separate limits with a multiplication sign between the two limits. And same with the quotient rule. The limit of the quotients, rewrite it as two separate limits. And you have to be careful here. Whatever zeroes out the denominator, you still have to tell the reader that, hey, I recognize that 0 can't be in the denominator. Okay, the limits of a scaled function, so here's a number being multiplied by the function that's called a scalar, is the scaling of a limit, meaning you could factor out that 3 and write it as 3 times the limit of x squared. So if we substitute 1 in there, 1 squared is 1, 1 times 3 is 3. And here, if we substitute in 1, we have 3 times 1 squared is 1. Well, 3 times 1 is 3. And then we finally have the power. And remember, powers can be integer or powers can be fractions. Usually when you see a fraction, what that means is the cube root. But when you're dealing with, in calculus, sometimes it's easier to write it as a fractional exponent, radicals. Okay, so the limit of the power, all right? So inside here we have 5x squared. If we substitute in 2, 5x times 5 times 2 is 10, 10 squared is 100. But the limits of the power is the power of the limit. So then the power, you're squaring. So if we had this item right here, the limit as x approaches 2, 5x, well, that's equal, 2 times 5 is 10. What this is saying is you square that result before you put the answer. And I think that is it for that. All right, that's it. And again, they get more complex. I'm just giving an intro, but sometimes you're going to be given the task, use the limit laws to find the limit, and then you have to break everything down. Well, before I go, so let me give you an example. If I have the limit as, say, x approaches 1, 5x squared plus, I don't know, 8x squared, Well, all of a sudden now you can rewrite that. This square right here, you can do this. You can square that, so that takes care of the power rule. But now we've got a scalar rule and two scalar rules, and we also have the sum rule. So using the scalar rule, we could write 5 times the limit as x approaches 1, x squared. And technically, this x squared, we could rewrite that as that if we're going to use all the laws. And then the limit as x approaches 1, this 8 can be brought out. So using all the limit laws, it would look something like that. Or you just type this information in, the substitution, which is much easier. 1 squared is 1, 5 times 1 is 5, 8 times 1 is 8, 5 plus 8 is 13, 13 squared is 169. And if you simplify all of that correctly, you should also get 169. All right, that's it.